Can anyone tell me what is common when I explain probability of all combination of A and B?
So can you explain can you repeat the question?
Yes. What is common in defining these probabilities?
Sample space.
Correct. Where is it? In the numerator or denominator?
Denominator.
Denominator.
No.
How many values in the denominator?
6.
6.
Why 6?
Because the number of outcomes are
Correct. Number of outcome in the sample space, but numerator are they same?
No, sir.
The
Yeah,
no, numerator varies as per the event, isn't it?
Yes, sir.
That is the reason I say probability is a number defined for an event associated with your random experiment. Which probability is high?
sir, A union B.
What is therefore the meaning of A union B?
Both the events would be happening.
Happened. That means
Yeah.
A union B will happen more often compared to others. Which is the least probability?
Intersection B.
Which means both will happen very rare if I perform tossing of the die. These are unconditional probability. No condition. Completely probability of the event defined on a sample space. Suppose I know that B will happen. What is the probability for A? Then the notation for this is probability A given B. Anybody? What is the
Probability
answer?
of A
From A
intersection B upon
intersection
probability of B.
B upon probability of B.
What is the answer?
Probability of A intersection B divided by probability of B, which will give us 1 by 6.
Correct.
One
It
by
is 1
So 1 by
upon
3.
By 3.
So
Sorry,
1 by 3.
This is called conditional probability. Conditional probability is a probability of an event condition on happening of another event.
So in this our sample space is probability of B.
Yes, three outcomes. Correct. You are perfect. He has only 3 outcomes. So the conditional probability has sample space associated to given event. So this is defined as the student told me, probability of A intersection B divided by probability of B. This is the definition. Question. 5 is unconditional probability, 6 is conditional probability. Therefore, throughout our statistical study, the probabilities are either on the whole sample space or it is on conditional sample space of another event. Question. Anybody clear the all work? Because I am not going to repeat probability from next day.
Yes, sir, it's clear.
So remember every time. Remember every time. When we define probability, it can be either unconditional probability or conditional probability. Conditional probability you can define if the events are not disjoint. Let us do once again one more example. A card is selected at random from 52 playing cards. A1 is card is spade. A2 is picture card. So I can define all the probabilities. Probability A1 equal to 13 by 52. Probability A2 that is equal to 12 by 52. Probability A1 intersection A2 3 by 52, etc., etc., etc. I can even therefore now A1 given A2. That is, you know, the card that you are going to take a picture card. What is the probability it is paid? Similarly, A2 given A1. You know it is a spade card. What is the probability it become a picture card? Clear?
Sir, is it 13 or 12? I am confused.
Where which one?
Sir, probability of A2 by A1.
A2 given A1. A1 is how many?
A1 is 13.
Of which how many picture card?
Yeah, 3. Sir, I got it. I was confused between. I got it. Thank you, sir.
But in your research area, you are not doing tossing of coin, tossing of a dice, playing cards. These are examples, hypothetical examples, which makes you clear how probabilities are defined. Let me do a real example. Let me do a real example. A customer coming to the shopping place and prefer a red label tea or other brand. A customer who comes at a shopping place will prefer either red label or he will prefer other brand. At the same time, let me make it in small font because the place is insufficient. At the same time, the customer is a male customer or female customer. Male customer or female customer. A survey is conducted among sample. So the male customers preferring red label tea will be 52, other brand will be 28, and the total will be 80 male customers are in the sample. "43" and 27. 70 are female customers in the sample. 95 prefer the brand. 55 prefer other brand is my survey result, survey data. Save one. Probability that a male customer is coming to the shopping place. How much? How much?
8 or 15.
8 upon 15 out of?
15.
Correct. 8 upon 15. 80 divided by 150. Probability of preferring red label. Answering
95 by 150.
95 by 150. Suppose the customer is male customer and he will prefer other brand. How much?
So would be 28 by 80.
No,
28 by 150.
55.
28 by 150.
But sir, okay, understood.
In third case, it is known that the customer is female. Find the probability that they will prefer red label. Now what is the probability?
So 43 by 70.
Correct. 43 by 70. So this way, you can evaluate the probabilities in real data also. You can definitely evaluate probabilities in real data also. This is nothing to do with coin, die, marbles, cards. Question here is, the shopping place, thousands of people are coming every day. And you are selecting a sample of only 150. This is the probability. Is it a similar probability when I take larger data? We don't know. Therefore, based on sample result, you have to project the result to the larger data. That is what main objective. And to reach that, you have to know the concept of probability. Never we go like this again. We have to know mathematical function form to evaluate probability. We have to know mathematical function form to evaluate probability. I'm going to translate all these examples. I'm going to translate all these examples in function form. Any question before that? Suppose a class consists of 60 students. That is, 45 are boys and 25 are, 35. 35 are boys and 25 girls. One roll number is selected at random from the class. X equal to 0 if it results into false. If the selected roll number is ball, we denote it by 0, which means it has certain probability. 35 upon 60 is the probability for that. I denote it by some notation. Some notation, any notation you can use. 1 minus p. And this is equal to 1 if the selected roll number is girl. That is 25 by 60 denoted by P. This means I can prepare a table X as the values 0 and 1 and the probability for X and probability for X, that is 1 minus P and P. If I know the value of P, I can get the probability for 0 and 1 as well. This probability can be written in another form. Bracketed 1 minus P to the power X multiplied by P multiplied by P to the power multiplied by P to the power X. See that. See the function. X is equal to 0. Put 0, you will get 1 minus P. Put 1, you will get P. This is called probability function. This is called probability function. A probability function is mathematical formula. Probability function is a mathematical expression which helps us to evaluate different probabilities, which helps us to evaluate different probabilities. Yes, any question? You can ask. You can ask.
Sir, could you please explain this?
Yes. Yes. I will explain all this once again because slowly I am going to higher level. Any probability evaluation technique, any, you can write in a function form. Whichever may be the area, binomial probability distribution you are going to study, normal probability distribution you are going to study, chi-square distribution you are going to study. Everywhere you are going to learn probability distribution. Okay, so I am repeating now. I simply told you probability is a number defined for an event associated with a random experiment. What is a random experiment? An experiment by which you can have collection of outcome and the result of the experiment is coming from it. For example, coin, H and T. This is the collection of outcomes. But when you toss a coin, you will be having either H or T, not both. Either H or T, but not the both. When you toss a die, collection of outcome will be 1, 2, 3, 4, 5, 6. Result will be out of it. Suppose we are considering two events, A and B. Then always you can have several combinations. There will be several combinations. But evaluation of probability will be either unconditional probability or it is conditional probability. Any of the example we have considered, evaluation procedure is on the possible outcome in the denominator. Numerator changes as per the event. A real survey also I have shown to you. But to study higher level statistics, the statistics, we have to know function form of the probability. Look here, I am considering a class of 60 students and one roll number is chosen at random. But the selected roll number may be either for boy or for girl. just like tossing of a coin. But I translate the experiment into notation form. X 0 if the roll number boy, 1 for girl. And the corresponding probabilities are 1 minus P and P. This finally you can write down as probability model for the experiment. And that is called probability function. If you put the value of x, you can get the probability. If you put the value of x, you will get the probability. So it is called probability function. I am modifying that now. Suppose two roll numbers are selected. From the class. Now y equal to x1 plus x2. x1 stand for first roll number, x2 stand for second roll number. What is the meaning of x1 plus x2? Anyone? What is the meaning of x1 plus x2? Anybody?
Sir, their joint sum.
What is the meaning now?
That in case if y is equal to 1, then probability is 1 minus p, and if y is equal to 2, then probability is p.
I am asking description of y. Y equal to how to explain verbally.
Y is cumulative distribution function of x1 and x2.
Yes, please. Y equal to?
The cumulative distribution function of x1 and x2.
No.
So selecting two students from class of 60 students.
Yes.
And summing up their roll number.
X stand for boy or girl. So what is to be done now? x1 plus x2.
So x1 or x2 could be either girl or a boy.
Yes.
And then that will depend upon x2 because one of the boys is already selected. So
Yes.
It would minus the denominator.
I am not asking probability. You people are confusing my question. What is the meaning of y?
It's a selection of two students from a class.
It is number of boys in the sample equal to either 1 or 2.
Yes, sir.
And now you say yes, sir.
Now I was saying the exactly same thing.
How, sir?
No, you never said this way. You have said in terms of probabilities.
Yes, sorry, sir.
I am asking no probability, meaning of y. अभी मैंने बताया every reality we are writing in notation. So every notation has a verbal meaning for your research.
Okay, sir.
Listen carefully. Every symbol, every formula, every notation, every function has a verbal meaning in terms of your survey work. Initially I said only X because sample size is only 1. But now I say X1 and X2. When Y will be taking the value 0?
When both the students are girls.
Correct. That is the meaning I want. Nobody should say X1 equal to 0, X2 equal to 0. That is mathematics. When Y equal to 1?
When one is a boy and one is a girl.
Correct. Maybe first boy, second girl, or first girl on second is a boy. And when Y equal to 2?
When both the students are selected are boys.
Correct. That is the way of explanation.
Okay, sir.
This is the way you have to explain. Now, I can prepare a table for this also. See the table. Zero, 1, 2. Probability 5. Zero. That means no boys. No boys.
It would be 1 minus p squared.
So I have to show this as girls.
P square would be
P square. Boy, 1. That means 2p multiplied by 1 minus p.
So
Yes.
we have assumed that X is 0 if the roll number selected is a boy, no? Then P
No boy. Yeah. So no boy. So I have to girls P. Sorry. In my earlier example, I have to show it is P and 1 minus P. You are correct. Thank you. 1 minus P. You are perfectly right. Yes. So now y equal to 1. So 2 times p into 1 minus p. And what is 2? That is 1 minus p bracketed power 2. And my probability function will be to C y multiplied by t to the power y multiplied by 1 minus p to the power 2 minus y. This is the function. What is 2CY? Y among two numbers are boys. P raised to y is their probability. Remaining are for the probability girls. Put y equal to 0. Oh, sorry. I made a mistake. Yes. Now, if you put y equal to 0, you will get p square. If you put y equal to 1, you will get 2 times p into 1 minus p. If you put y equal to 2, you will get 1 minus p square. So this is the probability function. This is called probability function. In general, if I select a random sample of n roll numbers, so now my y will be x1 plus x2 plus etc. plus xn. I denote it by n variable values. So y takes the value 0, 1, 2, 3, 4, etc. n. Either no boys or maximum n boys. So here my probability function of y is equal to same, but instead of I have 2, I say ncy n minus y and y. This type of probability function is called binomial probability distribution. Binomial probability distribution is denoted by BD. Bracketed small n comma p is the notation. Binomial probability distribution is a discrete probability distribution. Parameters are N and P. What do you mean by discrete? The variable can take only countably finite values from 0 to sample size n. Binomial probability distribution is a discrete probability distribution because the variable can take the values from 0 to n, countably finite. If you know sample size and the probability, you can evaluate probability of event in the sample. What is the event here? Y. See how we have started and where we have reached. You can define several earlier probability for this also. Evaluate the probability that sample has 4 boys and n minus 4 girls. Any probability you can evaluate. What is the probability that sample has less than or equal to 6 boys?
Hello, sir.
Yes.
Sir, can you see the formula, sir? I think there is something wrong. NCY p to the power y and 1 to the power 1 minus p to the power n minus y there will be. P to the power y into 1 minus p to the 1 minus p n to the power n minus y.
I have started with the notation deklo for 0, that for boy, which is 1 minus p. 1, that is for girl. So 0 means no boy.
Okay, sir. Okay, sir.
So when I say y equal to 0, there are no boys means all are girls, which is p raised to n. Of course, you can reverse otherwise if you define in the beginning. Is that clear?
Yes, sir.
So the probability function that we have defined here is NCY p raised to n minus y, 1 minus p raised to y. Every probability you can define because in the R package, unless you have function form, you cannot evaluate probabilities. You cannot evaluate the probabilities unless you have a function form. In our earlier modules also we have seen arithmetic mean is the function, variance VAR is the function, standard deviation ST is the function, and so on. So if to evaluate the probability also, you have to have a function form. This is called binomial probabilities. Binomial probability distribution is defined when your experiment will result either success or failure. Success means your favorable outcome. Failure means outside it. Only 2 parameters. N equal to sample size. P is the probability of success. In our example, P is the probability of getting the roll number girl. 1 minus P is the probability of getting a boy. And when you select a sample of n, you can have every probability in the sample. Okay, before I go next, let me ask certain questions.
Sir, I have a doubt.
Ask.
Sir, the boys and girls section where you have written that y is equal to x plus x1 plus x2, and you mention the probability y when it with value of y is equal to 2 is
Y equal to 2 means x1 is equal to 1, x2
and
is also 1.
I understand this, but the outcome of the probability I can't actually get it, like the p square and the 1 minus p and how that values are come.
See, that is what I defined in the beginning. Na? X is equal to 0, probability of selecting a boy will be 1 minus p, probability of selecting a girl will be p. And I am continuing that for x1 plus x2 or x1 plus x2 etc. plus xn. Clear, Shubham?
Okay, sir. Like you calculate this value from the data earlier that you have.
Yeah. You can use any notation.
Okay.
But you have to define clearly. I can define reverse way. X is equal to 0 for selection of boy denoted by P, and that of the girl will be 1 minus P, accordingly changing the formula, that's all. The notation has to be defined and accordingly you can do the function.
Okay, sir.
Therefore, when you speak about probability, in all these examples you have seen, probability is a number between 0 to 1. Now I am asking questions, nobody should leave.
Sir, just one question before we
Ask
start.
Rahul.
So we said like x is equal, like when we started this example, we said x is 0 if the selected roll number is a boy, right, sir?
With probability 1 minus p.
Which is the probability 1 minus 2. Now when we defined the variable y, which is number of boys in the sample, right, sir? So when we are saying number of boys in the sample, then we are calculating probability of y. So when there are 0 boys, got it. So both of them are girls, so p square. Got it, sir.
P raised to y.
Okay.
All are girls.
Okay, sir.
All are girls. Next, any other question? There is no revision for introduction? Naveen Roy?
Sir?
Do you follow the introduction of probability?
Yes, sir.
No problem?
Yes, no problem, sir.
Okay. Akash Singh.
Yes, sir.
Can you explain me your understanding of probability?
Sir, probability basically it's used for the sample analysis, also for our research analysis. How good is our research? It's a number defined for an event associated with a random experiment. Its value is between 0 and 1, sir.
What is the difference between conditional and unconditional probability? Now see, one student has left, 81 become 80 now. I have noted it. Okay, continue, Akash.
Sir, unconditional probability is probability in which we are directly given the event and we calculate. It's not dependent upon the other event.
Very good. Very good.
Whereas in conditional, the probability of an event is conditioned on the probability of another event.
Perfect. Perfect. Amit Ingale.
Yes, sir.
How to define binomial probability?
Binomial.
Yes, explain. How I have come to that function called binomial probability? Amit.
Yes, sir.
Okay, revise and prepare well for next class. Vinit Sharma. Vinit Sharma. Vinit. Pushkar Lakhe. Pushkar. Okay. Stuti Mehrota.
Yes, sir.
Do you understood binomial concept?
Yes, sir.
Explain.
So in binomial probability, there are basically two outcomes. Define the success as P and the number of are N. Basically, we solve the question on the basis of that. The failure will be 1 minus P. And
okay.
Yeah,
Can you give another example for binomial experiment?
Sir, occurrence of any event like so whichever event has two outcomes, I'm just not thinking at the
That is
moment.
what I'm asking you. In the current scenario in India and the global level, what is binomial experiment happening?
I'll get back to you.
Okay. Okay. Anjali Garg. Anusha Aush. Arismita Deka.
Yes, sir.
Do you follow the meaning of binomial experiment?
Yes, sir. Binomial experiment is any experiment when there are two outcomes, either a success and then a failure.
Yeah. So instead of my example, can you give an example that's happening in the global level now?
Global level, I don't know, sir.
Whole country, whole world is facing the problem. What is that binomial experiment? Anybody?
Sir, either you have positive or negative.
Correct.
COVID positive.
A person going
Sir,
for
will the vaccine will cure the COVID or not?
very good.
Or does not?
The success or failure of the vaccine.
Or not. Another example is that if a patient goes for checking, either he has a result positive or negative. Very good.
Sir, this will be the conditional probability, no?
That it is unconditional probability. I am going to check, nothing to do with others.
They're conditioned on whether he decides to go or not.
If I say the person who comes for inspection is a male, what is the probability he has a positive result? Conditional.
No, sir, the previous example you gave, whether if the person goes, so that is also a condition in itself, no? Whether the person goes or not, and then he will be
That is
tested
individual.
positive.
He has nothing to do with others. Am I right? But if I say the person coming is a male person, what is the probability then he has positive result? So this probability I am defining only for the male population. Follow? Follow?
Yes, sir.
You have to be well alert if you want to become a good analyst in future. You have to explain probabilities. Bharat?
Yes, sir.
Do you follow the meaning of binomial experiment?
Yes, sir.
Yeah. Therefore, when we define probability, initially you have to know this much. If you understood correctly the meaning of what I explained today, very easy for further work. And even if tossing of coin, tossing of a die, playing cards, marble, etc., are hypothetical examples, but the concept makes it clear and you can use that for other area. Shall I continue? Any doubt?
No, sir.
So, let me share again. And I will be continuing the last work of today's class. Look, how many value the variable y takes in the sample of n? How many possible values that y takes?
0 to n.
N1.
So how many are the count?
3 values.
N plus 1.
Correct. There are n plus 1 values for variable y. And this is called range of y. N plus 1 values of the variable we call range of y. So binomial distribution has a range discrete. Height of a student, is it discrete or non-discrete?
Non-discrete.
Non-discrete. So there can be non-discrete variable also. Their binomial distribution you cannot use. So we have to develop another probability model. Probability model depends on your experiment. Binomial distribution, Poisson distribution, normal distribution, hypergeometric distribution, negative binomial distribution, chi-square distribution, unending number of probability models. Everybody will do survey work, no problem. But when you come to the stage of analysis, you will find difficulty to apply the tool. So the best way to apply the tool, every session from now, listen, understand the assumptions behind each. Binomial experiment also called as repetition of Bernoulli experiment. Repetition of Bernoulli experiment. What is a Bernoulli experiment? Trial. Bernoulli experiment means trial. In coin, one coin. Roll number, either boy or girl. So statistically we call Bernoulli experiment. Can anyone tell me, tossing of a die, Bernoulli experiment?
No. No, sir.
No, sir.
Think seriously.
Sir,
Think seriously.
sir, if we are focusing on only single outcome, then it's a Bernoulli trial. So if I'm saying what is the probability of getting 3 in a single toss, so it's a Bernoulli trial. And if I'm doing it multiple times, then it would become a binomial experiment.
But in single trial, is it a Bernoulli trial?
Yes, sir. Like there can be only one value that can
So
be.
the one value called as?
So the outcome.
Success and failure.
Success or failure.
So what is success in the tossing of a die?
Sir, it depends if you want to have one or not.
Correct. Make it more clear. Suppose I define even number and odd number of the die, then it is success and failure, है ना?
Yes, sir.
Yes, sir.
Suppose if I define a number, prime number and non-prime number, Bernoulli. Suppose I define a number less than or equal to 4 and greater than 4, Bernoulli. So the experiment has 6 possibilities, but events are success and failure. Customer who comes to the shop will prefer either the brand or other brand, Bernoulli.
तूने खाना खाना है, अंदर लेता हूँ सामान.
Yes. Customer who comes to the shop to buy the tea brand, red label, or he will prefer other brand. So every time preference, choice result into two possible outcomes. Binomial probability distribution helps to evaluate probabilities in the sample. Standing in a queue. Destination is Deccan Gymkhana from my residence Koth Road. The coming bus, maybe I will get in or I may miss. So each person standing in the queue is Bernoulli and the queue is binomial.
So can you take that example again, please?
देख लिया. Reality when you want to speak in mathematics कितना मुश्किल है. Repeating, there are 20 persons are in the queue in a bus stop. Destinations are different. All buses are not going to the same destination through the route. So each one will get the bus or miss the bus. That depends on the capacity in the bus. Either they will get success or they will get failure. So each one is a Bernoulli trial and the entire queue is a binomial experiment. Is that clear?
Yes, sir. Got it.
Which says this way. Wherever you have selection result into success or failure, whether your choice is favoring you or not favoring you. And you are selecting a sample in the situation. To evaluate probabilities in the sample, binomial distribution will be used.
So that wouldn't be conditional again.
Tossing of a coin. Is it conditional, madam? Tell me. Oh, same thing. I am standing in the queue. I may get the bus, I may not get the bus. I am a coin.
So, but it also depends upon the destination, right? If number of people for a
That is
specific
what I
destination.
say. Plenty people are standing. Everybody has destination. The coming bus. Either they will get it or they will not. Am I right?
Yes,
Clear? Is that clear?
Yes.
So that is the reason I say wherever you have selection, choice, preference, that result either yes or no. Multiple choice question dekho, MCQ. Each question has only one correct answer out of 4. So your choice is at random, suppose. So either your selection is correct answer or your selection is incorrect answer. Bernoulli. And the question paper is binomial. A question paper has 10 choices, 10 questions. Each question has 4 alternatives, of which one is correct. So that if I compare with binomial, each question becomes a Bernoulli trial and the entire question paper is binomial experiment. Each question is Bernoulli and the entire question paper is binomial. Now anybody has doubt where to use binomial? Very few students are participating in clearing the doubts. I don't know what others are doing. This is the disadvantage of online class. Are they listening? Are they working? Nothing I can visualize.
So we are listening and working.
Only few students are responding. Now I have to ask and then they will answer me. Every day I am recording the students who are asking questions. Bhanu Sharma. Bhanu Sharma. See, no response. Bhavya Dang.
Yes, sir.
Do you follow what I am talking about binomial assumptions?
Yes, sir.
Okay. So this is what today's work. Now, did you receive the assignment sheet?
Yes, sir.
Did you receive the module 4?
Yes, sir.
Yes, sir.
Yes, sir.
Assignment. Assignment you have to submit by 23rd.
Okay, sir.
Plenty days are there.
Yes, sir.
Anybody has a doubt?
No, sir.
Not right now, sir. Sir?
Yes.
Sir, in the second question of the assignment, written
Yes, I am sharing you. You got the screen. In question 2, you have given less than cumulative frequency data. You have to convert that into frequency distribution and compute again arithmetic mean, variance and standard deviation. Is that clear?
Yes, sir. Yes,
Which
sir.
already we have done in module 1 and 2.
Yes, sir.
Next.
So,
Yes.
in the second question itself,
Yes.
do we have to use stepwise algorithms or do we have to use R? Can we use R functions?
Both.
Both. All right.
This assignment is for both.
Got it, sir. Thank you.
Question number 3. There are 3 variables. I asked here, arrange the data as a raw matrix and compute mean variance standard deviation of each shift. Answer also should be in matrix form. In question number 4, complete correlation regression. You have to compute stepwise, verify the answer by function. Very lengthy है. I expect everybody should work independently than copy from someone. In Symbiosis, when I taught this course, when I gave an assignment, many of the assignments I found independent work, but few of the assignments were true copies. I already told you, our objective here is not simply do the R course, get the marks and over. You have to know how to use this tool when you do data analysis. So this is an opening assignment number 1. Enough days. Today just 10, 13 days are given to you to do 4 questions. Who is CR of your class?
Yes, sir.
You have to collect the assignments, make a folder and submit in Google Doc.
Okay, sir.
So I can verify sitting at home.
Yes, sir.
Any other questions you have?
So how are we supposed to do it? Basically, we can do it in just one.
Yes. Editor. Our editor you have?
Sir, when we initially started this course, I did ask you if we can use Studio. So I remember you telling us that we can use Studio if we are comfortable, and that is why all my learnings that we have did in this class was on our Studio only. So I am more comfortable with our Studio. So would it be a problem if I submit the assignment on that?
No problem.
Okay, sir. Thank you.
No problem. So who is knowing this R Studio name, please?
Sir Rahul.
Sir, even I'm using RStudio.
Yes. Those who are comfortable with R Studio.
Even I am using RStudio, sir.
Yeah, do it.
And me too.
Yeah. So shall I continue my next sessions on the Studio?
Sir, it is more friendly, I think. So I think.
Yeah, it is easier to understand with everything there.
But if there are students, got late admissions, they are not familiar about statistical work in packages, so they used to ask doubt and difficulties. So anyhow, exam will be completely in R.
Okay, sir.
You do R Studio, no problem, very good. At the end, I will show. Any other question?
So we have to do separate questions and make a PDF of all of them, and then we're supposed to submit to our CR.
Yeah.
In PDF form.
Yeah.
Okay.
Editor है ना? Chart editor में करो.
So there is a compiler option in RStudio itself.
Yeah.
So you can Give the word file from there itself, right?
Right.
Thank you.
There is no much of a difference. Editor and console is always together in studio. That's all. Yes. Any other questions? Okay. So we have used here binomial distribution concept. Now when I use binomial distribution concept, I will be using the parameter n and p. Remember, n represent the sample size, p represent probability of success. N represent the sample size and p represent the probability of success. The minimum value of the binomial variable will be 0 and the maximum value will be the sample size n. So all the characteristics you have to remember when we do R package for binomial distribution. I may use function B binom, D binom, Q binom. So when I use such functions, you have to know the difference among the three and compute it. So when you learn mean and variance of a distribution, to conclude today's class, in the binomial experiment, the mean of x equal to the product NP, variance of x equal to NP and 1 minus p. That will help you for problem solving. Mean value of x will be NP, variance of x will be NP into 1 minus p. Therefore, in the next session, you are going to do probability techniques in R. Maybe conditional, maybe unconditional, whatever it may be. I may give a data or I may read from the file. Probability of what? I may explain and you have to compute it. Certain graph also you have to remember. And in the beginning of the next session, I will be introducing histogram. And after histogram, we are going for evaluation of probability. Any questions you have?
No, sir.
79 students, 2 students left. Manna Chowdhury?
Yes, sir.
You attended all the modules?
Yes, sir.
Okay. Nikhil Agarwal?
Yes, sir.
Have you attended all the sessions?
Yes, sir.
Rukshmini Datta?
Yes, sir.
Did you attend all the earlier sessions?
Yes, sir.
Okay. Okay. Shubham Kumar?
Yes, sir.
The question which you asked, you got it clear now, answer?
Yes, sir. It is all clear.
Yeah. Sonam Verma?
Yes, sir.
Any doubt you have?
No, sir.
Okay. So I will be stopping here today. All of you go through properly the revision of module 1, 2, 3. And today's class probability you have to read from Levin and Rubin. And also listen the Pat Obi video for probability for better learning of subsequent sessions. Okay. Goodbye today. Have a good day.
Yes.
Thank you, sir.
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 Yes.